In this video, we'll finish up chapter 3 by covering material from 3.5. Again, 3.5 has some good information at the beginning, just talking about how you communicate results, looking at a few graphs and charts. It's worthwhile reading through, and a reminder of several things that, again, I can't keep saying it enough. All graphs and charts must always be well labeled. I can't say it enough, everybody. How many people make quick mistakes because when I ask you for a graph or a chart in a paper or on a test, it's like, well, I assume. Don't assume. Again, you're still making it like someone brand new and fresh is looking at this. So those little details, what is the information? What are you collecting? Are there any units? Label your axes. All those are very important. But the second part, there's several things they note here, but a very big thing, it's about the fourth bullet. Keep your graph simple, right? A simple graph is more effective than one that has extra stuff, extra junk. The extra junk doesn't help anything. So the whole point of everything we said here is that these graphs and charts are supposed to make it easier for people to see the data, to get a taste for what that data represents, and to start making some most basic observations and, conclusions based off of that. So when you just fill in extra junk, it's distracting. So that's going to be one of the things that we discuss. So several things. The last thing I just want to point out in that first part is just when you're looking at published data, right? Always, where did it come from? That should always be completely clear. Is the display appropriate for the type of data collected? Are there any outliers? The book, we didn't formally define that yet, but the idea of a value that's extremely high or low compared to the other data values, okay? If we have a class that did well and pretty much everybody's in the 80s and 90s for their test grades, but one student got a 21, that's a pretty far outlier. If we're looking at how many miles are on your car and pretty much everybody's in that, 70 to 100,000 mile mark, but then somebody's got 400,000 miles on their car, that's pretty extreme. We're talking about height with the bell curve, the normal bell curve in the previous video. And again, we're looking at someone who's, average height of a man is 5'9". If a man is 6'2", 6'3", that's tall, but isn't an outlier. Well, we have more to go to formally define what it takes to be an outlier, but that's not really an outlier. That's tall, but you still see plenty of other people who are that tall. But if you start talking about somebody who's 7 feet tall, that's really rare. That's what we're talking about when we mean an outlier. So again, few little things to look at. They also start to mention the variability in the data. That's going to be its own separate topic. If we're looking at the bar graph, for instance, are our bars pretty much all the same heights? Is there some bars that are really tall and some that are really short? So that, again, the variability. Are most categories sort of equally represented, somewhat close to being the same represented, or are some categories really, really highly represented and others barely there? So again, I keep saying it, there's going to be more. We're going to get more practice going through all of this, but we've already said a lot. But now on page 129, they get into the cautions and limitations, which I want to formally call misuses. Now, misuses come by more than just graphs and charts, but it's probably the most common way people are tricked by statistics. People are shown something, as we've said in earlier videos, math is not a common subject that a lot of people like. So a lot of people, they hear some statistics, their brain turns off, whatever conclusion is made for them, they say it must be right. Happens a lot, everybody. A lot of people are guilty of that, but that's where a lot of us get misled. And the other thing I want to be very clear here, when I say misuses, these aren't little accidental mistakes. Someone plotted a point incorrectly, accidentally drew a bar longer than they should have, something like that. That's not what we're talking about. Those are mistakes. And mistakes, innocent mistakes happen, bad mistakes happen, but mistakes do happen. But what we're really talking about here, again, people intentionally trying to mislead. So the first thing they talk about, number one, Areas should be proportional. That's the goal. So what do I mean by that? Well, first thing, if you look at a pie chart, that's exactly the purpose of a pie chart. If you have a pie chart and have 4 pieces of pie and just draw that and then fill them in, that is so unlikely that each one represented 25% of the data. But that's a common thing people do. They just draw 4 pieces of pie, make them all the same size, and say, oh, this is blue, this is green, this is red, this is orange. Instead of realizing, thinking about favorite color, that like, well, green had so many more people that preferred it compared to orange. So again, that's the idea of proportional. But more than just something like a bar graph, a pie chart, in your book, they give you a little example, and we got to see how often people put silly graphics like this. This little picture of the cow. They're talking about milking more cows, and they put up this little graphic. But they're representing a barrel of milk, and in 1970, this barrel of milk is supposed to represent the average number of cows milked at a dairy farm. So in 1970, this one barrel represents 19 cows on average. But in 1980, there's 2 barrels. Well, again, if we have good math sense, if 1 barrel represents 19, 2 barrels should represent 38 cows. But it only represents 32. 3 barrels would represent 57 cows, but it only represents 52. Now, these numbers aren't terribly off, but just that using this big fat barrel, and it's not there. The information that they're looking for, that proportion, is not accurate throughout this. So what would have been easier? It would have been a lot easier to just make a bar graph here, to make it clear the 19, the 32, but again, trying to impress with an extra picture. This is the extra junk we're talking about. This picture does nothing for this problem. So that's a huge one. Areas should be proportional. Okay? Cautious with broken axes. This is what I was talking about, where I was saying I shouldn't just jump like with the test grades and start up here with 70, 80, 90. That's a terrible idea. I really should have started 10, 20, 30, 40, 50, 60, 70. That's where the 70 is. That kind of keeps the idea of proportionality, but also connects here. And now watch this. This is such a common way people can mislead through broken axes. Let's say we're comparing salaries. And we want to look at average salary, and we're going to compare that of teachers versus administrators. Sorry, let me fix that. 60, 65, 70, 75. That's what I wanted. So this is in thousands of dollars per year. And these are our categories. If you just look quickly, now I'm sorry my bar is a little off here. Let me fix that too. If you just look quickly at this and don't pay attention to the numbers, and this is exactly what somebody who makes this graph is hoping you would do, they would look at that and they would want you to see, wow, administrators make so much more money than teachers. These poor teachers, they're so underappreciated, they're so underpaid. And that's exactly what this graph shows. Because our brain, whether we're thinking about it or not, our brain likes things like proportion. Our brain likes things like scale. So our brain looks at this and looks at this bar as easily twice, if not 3 times the size of this bar. And then we start thinking things like administrators are doubling or tripling the salary of teachers. But that's not what we actually have here. And it's because we made such a big jump here. If I started this, and I'll show you in just a moment how this should have gone and how closer these bars really are. But by making a big jump and basically starting this off at $60,000 a year, so teachers on average are making a little over 60, administrators, I was aiming for a little less than 75. So it is clear administrators are making a significant amount more than teachers, but it's not this double or triple the amount. And if we did this correctly, now I've got it all starting from the bottom, right? Starting 10, 20. I'm going by 10s instead of 5s, but now I've got proper spacing. So now if I put teachers, get them a little over 60, and then get my administrators that's better. And here's the thing, everybody. That still conveys all the right information, but it does it in a good way. Instead of trying to mislead, you still make your point. Administrators make more, and now you're accurately reflecting how much more they are. It's a good amount, but it's not double or triple. Okay? That is a huge one to be careful with. Secondly, our book does not mention this, but I really think it should, because especially if you start looking at what's actually going on in the news, and I don't just mean the last couple years, I mean like the last 5, maybe more like 10 years, these things come up. This comes up a lot. This type of misleading, trying to make something look like a huge gap. And it doesn't have to be salaries, right? If we wanted to compare, who raised more money for charity, and it's like, wow, look, whoever this group is, they embarrassed this group. But no, when you get on the scale, it's like, good for you. You raised more money, but now we get a clear indication of how much money they raised as well. So again, we want that sense of balance, that sense of proportion. But another common thing, kind of goes along with the broken axes. Only having one number on your Y scale. So this is, I'm making it up. I'm not showing you an actual picture, but this was a graphic when we were looking at the initial enrollment of the Affordable Care Act. And there was a major news agency that did this. They pointed out the goal was 8 million people to enroll in the Affordable Care Act in the first year. Okay? Enroll. What actually happened? They showed this graph. There's your goal. And here's their actual. Can you even see a difference? I tried to make this because, like I said, this is what they actually showed on television. They showed this, and if you look really closely, the actual is a little higher than the goal. So with that statement, you would say, well, was the enrollment successful? And most people would look at that and just say, yeah, they met their goal. But if you actually do a little bit of research and see what was the actual number, because when you only have one number over here and you're not showing any sense of scale, all you get is this is a little bigger or a little small. I mean, they could exaggerate it more, but that was their purpose, was just to show this is a little bigger or a little smaller. But the actual enrollment was over 9 million. That is not being represented in this graph. Now, the reason they did that, they wanted to show it was like a begrudging admission of like, well, they've made it, but they barely made it. As opposed to showing the proper graph, 1, 2, 3, 4, 5, 6, 7, 8, and 9, to clearly show this was the goal and this was the actual. That would make it clear to say not only did we make it, but we clearly made it. So this was an actual graph. There's another one I'll show you in just a moment that'll come up with time series charts. But just to stick with this for one more moment, because thinking about this, everybody, it's a very likely question that I'm going to ask you at some point to give me an example of a misuse of statistics. So you're going to have to explain a situation, show a graph, and talk about what's wrong with it. And you could always take one of these and easily manipulate it into your own example. But this one is a little harder for people to see. So let me show you a different one. Let's go back to fundraising again. And I show you a fundraising chart. And I do almost the exact same thing. Our goal was that we were trying to raise $25,000. And here's the actual. Can you see the difference? I'm trying to do almost the same thing I did here, but reverse. Here the actual is just barely over the goal. Here the actual is just slightly under the goal. So that if you show this to a presentation, right? Think about this. Think about this in the workplace. It's so many different presentations in business and accounting and marketing and all these different areas. And for a lot of it, you're trying to, kind of show yourself off a little bit. So if you show this, most people would take a quick glance, say, oh, hey, we just missed it. Good for us. We raised a lot of money. We just missed it. But without having a second number here, we really have no idea how short this is. And all it takes is one more number. Once you get one more number on this, now you can't manipulate that second bar so easily. So maybe we actually only raised $15,000. We're not even close to that goal. But according to this graph, that's accurate. It's less than the goal. So what I'm showing you is accurate, but it's misleading. One more time, you put the actual full scale together, 5,000, 10, 15, 20, 25,000. There's the goal. There's our actual. And now we can take a real close look at reality and say, okay, hey, 15,000. Well, maybe that's still a lot of money. Maybe we're still happy with that. But to realize how far short we really were. So that's a really good start with misuses. Let's continue. And now number 3, we get into that time series chart. Unequal spacing. And again, 2 good pictures in the book. And they're just trying to give you this little scale. Actually, I'll show you. It's easy enough to just drop this in here. They show a time scale. And if you look quickly, you look 94, 95, 96, 97, 98, 2000. And that makes sense. You're going one every year, although we missed 1999 somehow in there. But it kind of makes sense. But also notice the date. January 94 to May 95. That's more than a year. May 95 to May 96, that's exactly a year. May 96 to December 97, that's much, much more than a year. Then we get a year. Then we get over 2 years. Then we get over a year. These are all different gaps. So this makes it look like they're all the same. But then look at the bottom picture. You don't have to have all the exact same dates. You don't have to do this January 94, January 95. You can do it, but these dates should be representative. That from January 94 to May 95, a greater period of time has passed than has from May 95 to May 96. Then a bigger gap, then a smaller one, then a bigger. That's the way to appropriately show that. Now, why would you do that? What's misleading about that? That's where we really need to start talking about more situations. And often it's trying to hide that we're losing money, right? If we want to showcase, if we're looking at maybe, again, a company and we're looking at our profit and this is our year, and we want to really highlight how long we're making big money, because profit, realize you could lose money, so you could get negative profit. So let's say we made money in 2010, 2011, and then we lost money in 2000, so 12, 13, in 2014. So we gained money, we still made a profit, but we made less profit. Here we lost a lot of money. So your time series chart, that would be appropriate. But, and then maybe 2015, we're back to profit. But that really showcases that it looks like there's a lot of years of losing money. So if you just did this, it looks more like a momentary blip. You could still see, that there's some time that you didn't do as well, that you lost some money. But by having these as equal gaps when they're really not equal, it can kind of try and hide how long something good, you can exaggerate how long something good happened, or you can exaggerate how long something bad happened. But either way, that exaggeration is misleading. So, since they brought up the time series charts here, I think this is a good time to bring up another example. This is not unequal spacing, but this is just poor labeling. Now, if we had a situation where, let's look at the unemployment rate. Unemployment rate by year. Now, I apologize, I kind of forget these numbers, but once again, just like the Affordable Care Act enrollment, that initial rollout, that was a real graph that was presented, and so was this. This one had our years, percent enrollment, unemployment, percent unemployment. So just to make this a little easier, let's just jump up to here. That's 5%, and there's 10%. And then they had several years, 2008, 9, 10. And they did this. We did here. That's basically the chart that they showed. And what you would see, what most people saw when they looked at that, they saw a nice little drop at the beginning, and they basically saw everything stay flat. But then when you actually look at the numbers, I believe, again, I'm making these up, but this was something like 8.6, this was 7.2, then this was 6.1, then 5.1, and then like 4.9. Do those even closely match up to what we have over here? 5.1 should be about here. 4.9 should be below 5. They're just completely not lining up their numbers to make it look like unemployment was